So, hello everyone for this session. I say it. Thank you. So, this session about the ecological footprint of research in planetary science. I will first give a brief overview of why we wanted to get such a discussion here and why it's important. And then we will have a presentation by Luigi Tibaldo before we can discuss together about, so first in small group about some of the issue and how to address them, and then all together again. So, okay, now it works. It's because I'm taking it upside down. Okay. So, why do you want to care about ecological footprint of something? There would be lots of ethical reasons or ecological and so on. So I will skip those ones because I assume most of you are already aware of that. So let's try to focus, if you are very skeptic about the ecological ethical thing, why as a scientist you should worry, why as an astronomer you should worry about climate change. So first of all, Caroline Hasselbachler and other people in 2002 released a paper about the impact of climate change on observations from the ground. And so they studied like for 8 different big observatories, including in Chile or Hawaii, what would be the impact of the climate change in terms of observing conditions. So it might be the like the seeing or like the temperature and so on. And for all the sites, there is an increased projection of temperature and humidity at least, which leads to poor astronomical observing conditions. The cloud coverage is very difficult to evaluate for these kind of things, and they are actually refining because you need better model for climate, but it should also be worsening, and the thing is very difficult to evaluate also as one thing, but the dome thing should worsen and this kind of thing. So conditions to observe should worsen. Behind that, you can also have direct threats from fires. I saw a talk online by Dr. Faustine Cantalub, and I was quite shocked to see this image of Mount Stromlo in Australia, which was on fire in 2003. I had never heard about it, despite it being 20 years ago, but I find it's quite a shocking image to see an observatory in fire. This observatory was on fire because of wildfire in the forest. And so in the USA, the number of wildfire, it's the same, but their intensity is growing and growing with climate change, as Dr. Faustine was saying. And I will put in WOVA the link to the different studies and, for example, to the talk by Faustine Cantalub if you are interested to learn more. So those are some of the elements. And if you take also the fires, so this is a map of the different fires, you can see that the optical depth is increasing. So of course, worse condition to observe. And also sometimes the humidity level or like some specific gas. So if you want to do spectroscopy, it's also messing up everything. And finally, climate change, addressing climate change is, and this kind of things is one of the SDG goals, so Sustainable Development Goals from the United Nations, which is always something that is appreciated when you apply to grants and so on, when you say, okay, we are going to work towards those SDGs, those ones. Another one which is often done is about quality of education and gender equity in science, but climate action is another one where we can also bring our little stone to the edifice. So, and beyond that, astronomy is a black sheep of sciences and also particle physics. So lots of science have different impact, but yes, astronomy and particle physics are among the worst science in terms of ecological impact. Luigi will tell us a little bit more about that. And there are a few reasons, for example, the numerous travel for observation in remote locations, large numerical simulations, or the consortia that need to send lots of different bits of instrument. When you build a satellite, it's many travels, and this increase our carbon footprint as scientists. And so the community is not passive so far. It's acting, and there are local actions. There are actually lots of local actions. I've picked up 2 examples. The first one is the Sustainability Committee of Leiden Observatory. And for example, they are working on getting data from their observatory, but also other place in the Netherlands, and to estimate the carbon footprint of all of astronomy in the Netherlands. And another example is the Sustainable Development Group in Geneva, which is also acting more on a very local level. For example, the Geneva Observatory is in the middle of a forest, and it's on several sites. So it's very difficult to reach, no public transport really to arrive there. So they are putting in place measures to help reduce the carbon footprint on daily life, I would say, such as putting in place electric bikes that you can take to go between the different places of the observatory and so on. Very simple examples. There are much more to say, but I'm not from the observatory, so I will not elaborate more on that. And so those local actions, they are usually doing 3 different things: collect and analyze data, inform their researcher about sustainability and how to increase it, and also implement some actions very locally, once again, and best practice for sustainability. We also have international and national groups that are working on this, like Labo 1.5 in France, which is for all science, not specifically astronomy, or Astronomers for Planet Earth, which is this one focusing on astronomers and which is worldwide. And actually they are in something like 75 countries with 1,500 members. And for Labo 1.5, actually there are 550 members, more or less, and they have a tool for evaluating the carbon footprint of labs, which is, I think, mandatory in France to evaluate now your carbon footprint. And so they provide tools and so on for 800 labs or so. So yes, there are actions. And again, they collect and analyze data, provide tools, inform about sustainability, and give visibility to the issue. The problem is that usually it's, again, like for example, in Labo 1.5, it's people who are dedicating 5% of their full-time equivalent job. It's never people who are working just on that. It's always people who are doing that as a side project to their science. And it might also be an issue, because if you want to collaborate, you need to get your hierarchy to be agreeing with that. It can lead, though, for things like a conference about the sustainability in astronomy organized by Astronomer for Earth, and they had more than 500 participants. So we can see there is really a big interest from the community to discuss this. Finally, there are institutional actions, and they are mainly for now concerning the daily life aspect, but you can have, for example, travel rules, or ESO also, for example, has decided to upgrade all their observatories to get renewable energy. So, for example, LACIA has this big power plant to be able to observe. So in terms of travel rules, I take the example from where I am at the University of Bern. Now we have a green light system. So from Bern, you are not allowed to take, basically in the green area, a plane, not at all. If you are in the yellow area, it means that you can take a plane, if the difference between train and plane and so on. So they try to reduce the impact with such measures. And also ESA has a green agenda. Again, for ESO and ESA, I will put the link on WOVA if you're interested to learn more. So there is discussion already happening and lots of local actions, some international ones, but very few institutional, and in particular at European level. So that's why today we wanted to start such discussion, as Europlanet is quite willing to initiate discussion and support initiative. We wanted to have such a discussion amongst us, given this week theme is to build a community. So as a community, we need to come and tackle this problem. So the schedule for this meeting will be first a presentation by Luigi Tibaldo from ERIM. And then we have a few minutes for discussions. Then we will have 4 main themes that people can split and discuss together, and then we will reconvene all together and summarize these points. So I will give the floor to Luigi so he can present to us why astronomy is not such a great science for ecological footprint and the different footprints of different space missions, or do observatory on the ground compared to that, and so on. So yes, Luigi has joined us remotely, so we can switch to him. Hello, Luigi. Can you hear us?
Hello, good morning, everybody. Can you hear me fine and see my slides?
Yes, perfect. So the floor is yours for the next 30 minutes.
Perfect. Thank you very much for the invitation. Thank you for having me. So my name is Luigi Tibaldo. I am from ERIM in France. I am actually not working in planetary science. I'm working in high energy astrophysics. But Thibaut invited me today because together with some colleagues here at ERIM, we've made some work on the carbon footprint of astronomical research and in particular of astronomical research infrastructures. That is interesting for you, I'm told, to consider in the context of the discussion you plan to have. So let me start with a broader context, going through some of the material that Thibaut skipped over, so that I'm sure that everybody is on the same page in terms of why we are doing this. On this slide, I have some plots from one of the IPCC reports, the International Panel on Climate Change. On the left, you can see the changes in global surface temperature reconstructed over the past 2,000 years and then measured since 1850. So you can see that since 1850, we are seeing a marked increase by, at this point, almost 1 degree in the global surface temperature on Earth. And on the right, you can see zoomed in this part of the graph, and you can see the results of simulations, either based only on natural factors like solar activity or volcanic activity in green, and including the impact of human activities, especially the exploitation of fossil fuels in orange. And you can see that actually the increase we are seeing, according to our best knowledge, is due to human activities. Where is this leading us? On the left graph here, again from IPCC, you can see projections for the future. There are several scenarios, and you can see that there are actually scenarios that predict a further increase in the global temperature on Earth that could reach 5 degrees by the end of the century, with respect to the pre-industrial era average, and some scenarios that at best keep a 1.5 degree increase. And on the right, you can see some risk assessment related to this increase in the Earth temperature that could have very high risks related to extreme weather events or other events that have a large impact on human life on Earth. So some colleagues of mine and I here at ERIM got very concerned about these topics, and since a few years ago we started trying to figure out what we should do as researchers in astronomy about these issues. And we formed a group that was recognized by the direction of our institute and is represented at the Institute Council. And we started to have regular interactions with other researchers elsewhere that are working on these topics, and also with the national and international networks. So a few years ago, finally, we decided to start by conducting a detailed assessment of our greenhouse gas rejection that was endorsed by the Institute direction in 2019. 8 of us actually followed a 40 hours training on one of the established greenhouse gas accounting methodology that is called bilan carbone, developed in France, which is also compatible with other standards in GHG accounting like GHG protocol or ISO 14064. And after taking this training, we realized that this methodology that is widely used was working fine for us for most things, but there are no ready-made tools to deal with something very specific to astronomical research, which is large shared research infrastructures. By astronomical research infrastructures here, I mean space telescopes, space probes, studying planets, interplanetary plasmas, and so on and so forth, and ground-based observatories. And one question that you may ask yourself is why we should consider the footprint from infrastructures as part of our own footprint. The bilan carbone methodology that we were trained at actually prescribes to include in your greenhouse gas assessment all the fluxes from which your organization is responsible and on which your activity depends. So basically you ask yourself a question: will your activity be impacting if one removes a certain flux? And of course, if we remove astronomical research infrastructures, our research in astronomy will be strongly impacted. We depend on those. And so we have to take their impact into account when we assess our carbon footprint. Furthermore, obviously, astronomers have some responsibility because it's us who invent research infrastructure, and it's us that contribute to build and operate the infrastructures. So we are co-responsible for those. And without astronomers, obviously, there wouldn't be any astronomical research infrastructures. So the method that we used, that we developed with my colleague Jürgen Knödelseder here at IRAP to have a first estimate of the impact of research infrastructures is actually very similar to that used in any other specific item. That is, we need to define the boundaries. So, for example, in our case, we considered the research infrastructure used by IRAP researchers in 2019, and we tried to account for all the different scopes, that is, for construction, launch, for space instruments, and operations. Once you have defined your boundaries for every item, for every infrastructure, you need to collect activity data. That was the most difficult part of the job because there is hardly any public information on the activities of astronomical infrastructures, and especially for space infrastructures, there is quite a lot of secrecy. So at the end, we decided to limit ourselves for this first estimate to very simple activity data that consist of the cost of the missions or projects and the payload weight for space infrastructures. And we applied what is called an economic input-output method. That is, we assumed that the carbon footprint of an infrastructure is proportional to its cost or its weight for space infrastructure. And I want to stress this. Of course, this is not at all the most precise way to estimate the carbon footprint of an infrastructure, but it was the way we chose to have a first estimate because of the limited availability of activity data. So the first step was to derive emission factors, the proportionality factor between cost or weight and the carbon emissions. We derived these emission factors from the few examples that we could find of astronomical infrastructures that had estimated their carbon footprint. So for space missions, we based it on two space missions. And for ground-based observatories, we had access to data for 2 ground observatories for construction and 3 ground observatories for operations. And the emission factors that we obtained are listed here. So we had about 50 tons CO2 equivalent per kilogram for space mission based on payload mass. And for the monetary factors, we obtained 140 tons CO2 equivalent per million euro for space missions, and 240 and 250 tons CO2 equivalent per million euro for construction and operations of ground-based observatories, respectively. So, of course, this is only a very rough estimate, but one point that I want to make clear is that probably these are lower estimates for 2 reasons. First reason is that we could not always meet our boundary goals. So sometimes there were posts that were not included. And also because if you take our monetary emission factors that range from 140 to 250 tons CO2 equivalent per million euro, and you compare it with other activity sectors in society, here you have comparison with soft activities from insurance, banking, to more material consuming activities like production of metal or minerals. You see that our factors are on the low side of what is currently estimated. So for all these reasons, we think that our estimates of the carbon footprint is probably a conservative, low conservative estimate. So on this slide, I copied the activity data that we collected. The collection of the cost data was the most time-consuming part of this work, while the collection of payload mass is relatively easy. And as I mentioned earlier, we did not always manage to respect the boundaries we had set for ourselves, because cost data do not always include, for example, mission extensions and never include upgrades. If no data were found, we skipped the contribution. And in this sense, our results can be taken as lower limits. All the cost data were taken and corrected for inflation to 2019 economic conditions. Here I copied the results for the research infrastructures that we studied. Beside the individual values that you can find in this table or in our paper, I want to stress that this is just an order of magnitude estimate. The results of for individual research infrastructures are highly uncertain. If we take the recommendation by the French environmental agency ADEME for the economic input-output method, we shall assume that the uncertainty is 80%. Once we have the total footprint from for a given infrastructure, we can obtain an annual footprint by dividing the total footprint either by the total duration of the project or 10 years if the project is younger, under the assumption that the data will be exploited for at least 10 years. So these are the aggregated results now that we obtained. For space missions, we have 2 estimates that are either based on cost or mass. You see that the 2 agree within the uncertainties, and they correspond to 5 to 6 megatons of CO2 equivalent, with an annual footprint that ranges from 300 to 370 kilotons CO2 equivalent per year. For the ground-based observatories, we have 3 megatons CO2 equivalents total and 194 kilotons CO2 equivalent per year. But this is only for the 85 research infrastructures, the data from which had been used for research at IRAP in 2019. So what we tried to do was also to extrapolate to the total number, to the entire population of infrastructures existing in the world. We did this using a bootstrap method. So I just want to highlight here the total. You can see that actually there is a moderate increase for the space missions. This is because our lab, ERIM, is a strong space lab. So we are using a majority of the existing space infrastructures. The increase is much more marked for ground-based infrastructures because here we are not as strong in the use of ground-based instruments. You see that we get to a total that is 21 megaton CO2 equivalent and an annual footprint which is over 1,000 kilotons CO2 equivalent. What we did also to put this in context to make the numbers easier to understand is to take the annual footprint and divide it by the number of astronomers. So we obtain the footprint, the average footprint for a person that is involved in research. And this gives around 37 tons CO2 equivalent per year per astronomer, which is a number that you can compare with, for example, the average of a European citizen that including both the lifestyle carbon footprint and the professional carbon footprint is around 10 tons CO2 equivalent per year per person. So you see that astronomers emit a lot more on average than average citizens. Now, putting this back into context, we also estimated, of course, all the other carbon emissions from our activities at ERIM. And here you have a pie chart that shows the relative proportion. You see that the most daily life emissions like consumption of electricity, heating, water, the commuting from home to the lab account for small fractions of the total footprint. The locally controlled posts that contribute the most are professional travels, around 16%, and the purchasing of goods and services, which is around 18%, but the total is dominated by the research infrastructures that altogether account for more than half of the carbon footprint of our lab. I wanted to compare this with estimates of the carbon footprint provided for other astronomical organizations like astronomers in the Netherlands, MPIA in Germany, or the Australian astronomical community. You can see that there are huge differences among the estimates, and that in part this is related to the fact that so far not everybody has been taken into account the carbon footprint from the infrastructures. For example, it was not taken into account in the estimates from the colleagues in the Netherlands or at MPIA, or it was only partially taken into account for the Australian community because they only took into account the electricity consumption of infrastructures in Australia. So this illustrates the importance of considering all sources of greenhouse gas emissions. Now, one question that we should ask ourselves is, what is our target to meet the climate agreement to keep the global temperature increase within 1.5 degrees? If we look at the example of a ERIM staff member, his lifestyle footprint is small compared to the professional activity. And in terms of professional activity, the footprint is dominated by research infrastructures. We cannot really answer ourselves in our small group what the target should be, but I will just give you some examples just to have a rough idea of what is the reduction that is needed. So the International Panel on Climate Change tells us that by 2050, every human on average must produce no more than 2 tons of CO2 equivalent if we want to keep within the 1.5 degrees. So we could say everybody produces the same emissions, So astronomers as well must emit at most 2 tons of CO2 equivalent. Of course, this could be seen as being too harsh, and we could say that some activities in our society are important and we want to keep them even if they emit more than the others. So one approach could be, for example, to say that everybody must reduce by the same amount so that on average we get to the 2 tons per person. For a European citizen, this means to reduce by a factor of about 5. But there could also be another approach to say that the people that so far have been most responsible for the climate breakdown must reduce more than the others. And if you take this approach, then astronomers and European citizens in general must reduce more than the others. In all cases, the point that is important, even though the exact goal is not known today, is that it's clear that astronomers must reduce their carbon footprint and must reduce it by a lot. So how will this change the way we do astronomy in the future? Estimating the carbon footprint is only the first step. A carbon footprint analysis is only complete once we have an action plan to reduce our footprint. And here is the proposal that we came up with the colleagues at my institute. So first of all, the existing facilities should develop quantified action plans to decarbonize as much as possible the operations, which includes, for example, operating centers and ground stations for space missions. Existing and planned facilities should perform an environmental life cycle analysis, that is a more refined evaluation of their carbon emissions, which will make it possible to define and adjust the action plans for the existing facilities and make decisions on the implementations for future facilities. The progress of the action plans should be monitored and plans should be adapted if needed. And analysis, plans, and monitoring should be made public. One of the big limitations, as I explained earlier, is that today most of these things are kept kind of secret. And the approach, I wanted to stress also that this approach has actually been recommended recently by the Astronet Science Vision Roadmap. So one important question is, are carbon footprint reductions enough? Here, I will take the example of ESO, and not at all to blame ESO. On the contrary, ESO is one of the exemplary astronomical organizations that already disclosed information about their carbon footprint and have a plan to reduce it. So this is really amazing. Here you have the estimate of the carbon footprint from ESO in 2018. And ESO actually developed a plan for the reduction that is going to reduce the carbon footprint by 15% over the next few years. However, there is an issue with this carbon footprint reduction plan, that is that it takes only into account existing facilities operated by ESO. And it is to these existing facilities that the minus 15% applies, coming mostly from the deployment of facilities to produce renewable energies. However, at the same time, ESO is also developing new infrastructures, in particular the ELT, the Extremely Large Telescope. They already estimated the carbon footprint from the construction of the ELT, and by taking this into account, actually, you cancel out the improvement from the carbon reduction plan, and you go past the current operation plan, the current emission. And if we take into account operations, it is certain that ESO will actually see an increase of its carbon footprint. This was estimated by my colleague, Jürgen, using publicly available data, just from one post that is, however, one of the most important ones, that is electricity. Here you see the electricity consumption from ESO as a function of year and converted into carbon footprint. So you see that there is, sorry, I locked my screen. I need to unblock it. Yes, so you see that there is an increase in the renewable electricity that is exploited by ESO in green, but the electricity consumption of ESO over the next few years is going to largely increase due to the operations of the ELT, as I just mentioned. And as you see, overall, there is an increase of the carbon footprint. So going back to the question, are carbon footprint reductions enough? Actually, according to our view, there is an inconvenient truth that we need to take into account. It is extremely difficult to decarbonize if at the same time you try to ramp up. So we need both a carbon footprint reduction and a reduction of the deployment pace of the new research infrastructures if we really want to sizably reduce the carbon footprint of our activities. So what can we do to go towards sustainable astronomy? As I mentioned at the beginning, if we want to keep our planet habitable, human societies must switch to a sustainable socioeconomic pathway. This concerns all human activities, so we must include also astronomical research. And this, in our opinion, likely implies that we have to reduce our dependency on new and ever bigger research infrastructures. We can, for example, think about a deeper use of archival data that are largely available and underexploited today. We can make decarbonization of the existing facilities a priority for the use of funding. And finally, think about how we can build less new facilities. This is certainly an enormous systemic change in the way we do astronomy, including individuals, laboratories, research and funding organizations, and finally also governments. But as a community, I think with my colleagues that we should recognize our responsibility in the climate breakdown and try to be as exemplary as possible, also to give credibility to research in astronomy and in climate science. Thank you very much for your attention.
Thank you very much, Luigi. It was a very, very interesting presentation. Now we have a few minutes for questions, if anyone have any question. If not, for maybe kickstarting. In your publication, I think there was also another metric you used that was to estimate for each space mission and ground-based observatory the footprint, the carbon footprint per publication resulting from this space mission and so on. Can you tell us a little bit about that and some of the conclusions?
Well, that was, in fact, the problem that we tried to address in our publication was, of course, astronomical research infrastructures are shared facilities. So we were wondering, in the context of estimating the carbon footprint of our lab, how we could split the total emissions from an infrastructure among the different people using the infrastructure for their work. And so we tried to do different ways of splitting. In my presentation, I gave you only like the simplest and most rudimentary one, that was to split the total emissions by the number of astronomers in the world. But then in our publication, we also considered the other metrics like dividing the footprint of each infrastructure by the total number of publications making use of it, or for example, by the number of individual authors having published based on the data from the infrastructure. I can't remember the figures on top of my head, but that is not very important, I think, for the discussion we are having today. You can find them in the publication.
But I think it's important to keep it in mind, this kind of evaluation also, because sometimes the reduction must be also done depending on the actual science output of a mission. Maybe it's better to select what to decarbonize first based on the science output, and to limit the pace of increasing new like facilities, also aim for the ones that will have the best science output for a given carbon budget.
Well, for the new facilities that can't be estimated before the facility is constructed, so I'm afraid it won't work. For the existing facilities, honestly, I can't really make a recommendation myself on what should the criteria be to set the goal for each individual facility. But what I can tell you is that I do believe that all facilities should try to decarbonize as much as possible their operations.
Thank you. Any other question? Yeah, we have one there.
It's in the chat. I think Ulysse, you had a comment you wanted to ask.
This was really amazing, and this was truly, I think, an important statement to make. I just wrote in the chat that your concluding remarks, I am deeply agreeing with them, but this is a bold statement to make, considering that science in general and astronomical science in particular is bound to develop in the next few years. And although we are aiming for credibility and being exemplary in the way we do things, there is still a lot of issues with trying to tell scientists as individuals to, well, maybe try to reduce their carbon footprints, but also to science institutes in general and science policies at the different national, international levels to try to reduce activities, because it's also a geopolitical issue, I think. And so I was just wondering what you thought would be possible based on the action plan that you're sharing with us.
Thank you for your remark. I totally agree with you. This is the most difficult issue that we are facing. Try to figure out how we can essentially change the paradigm that we are currently working in. That science consists of developing ever more and ever bigger research infrastructures, which is also tied, as you said very correctly, to geopolitical issues. I don't have an answer, unfortunately, now, but I think that it is important to keep discussing the community and figure this out together. I can mention that on one hand, this kind of discussion is spreading in the community. For example, here in Toulouse, we are having the same kind of discussion with colleagues from neighboring fields like geoscience, oceanography, atmosphere science. And as I remarked in my presentation, the recently published, how is it called, in the roadmap, Astronet, Science Vision Roadmap for European astronomy, includes a statement that the development of new facilities and the operations of existing facilities should take into account the reduction of the overall carbon footprint. So I think even that is almost symbolic at the time being. That is a very good first step, and I hope that as a community we will be able to push this forward in the next years. Although I must admit, not everybody in the community agrees on this.
Thank you. Any other? Oh, yes, we have another question there.
Yeah. Hi. Thank you for the great presentation and the work you have done so far. My question is about all the proposals were in direction of constraining the carbon footprint. Are there any ideas of recovering the carbon footprint, like producing oxygen or something in this way of thought?
Oh, you mean like compensate for the carbon footprint by having like forest plantation or carbon capture, stuff like that?
Yeah, yeah.
So I'm not an expert on this point, but I will share what I know. For carbon capture technologies, there is not an estimate specific to astronomy, but there are estimates that are made by IPCC that are related to human activities in general. And the estimates from carbon footprint at the IPCC are always included in the scenarios I was showing at the beginning. But the conclusion of the IPCC experts is that the current technologies for carbon capture are not even nearly efficient enough to guarantee the net emission reductions that are necessary to ensure the goal to keep the increase in Earth temperature within 1.5 degrees. For what concerns compensation, that is, for example, plant forests to compensate for your emissions. Well, on one hand, the effectiveness of these measures is quite controversial among the experts. And when I was trained in bilan carbone, one of the things they really stressed is that you should never take those into account in the projections for your carbon emissions, because that is like cheating. Those things are not immediate. They are not in the same place and in the same time frame as the ones, as the emissions that you produce. So it's like saying, okay, I can emit today because in 100 years, the trees I have planted will be able to produce, to capture the carbon that I have produced. And of course, that is not working in order to limit the negative effects of the carbon emissions. So it's a good thing to plant forests or whatever else, but that doesn't exempt us from reducing our carbon emissions.
Thank you. We have time for one last question before we go to the next part. So if there is none, we can come to the next part of our discussion. So I'm going to reshare the screen if it's possible. Going quickly through the slides. Oops. And I went too far. Slideshow. Okay, so now we'd like to get a little discussions. So we, as Luigi mentioned, it's actually funny because lots of points that I had put as potential discussions were mentioned by Luigi, also like the fact that we need to change how we do and who can act, that it's not only institutes but also individuals and the community as one. So I propose now that we have set up like 4 boards to discuss a few topics, and that you can go to the boards and discuss in small groups for, let's say, 15 minutes before we reconvene and talk together about the points that have been discussed, to address a few points, for example, but feel free to discuss other things like, oh, we can improve the sustainability of each research infrastructure on a daily basis with things like remote workings or reducing seminars and colloquiums in institutes. One big topic, I think, because it's lots of travels and so on, is conferences, meeting between astronomers and so on, that we need to reduce on. So we have a board for that also there. We also have a mural that you can join and put online, or I will also put the link to the mural on Wova for online people. And then also we have like a kind of a target, and I would be interested for, in your opinions, what you think is what individuals, like astronomers as individuals, can work on, what is dependent on the community, like our conferences depending on each individuals or the community to change how it works, and also what is the responsibility of the institutes rather than each astronomers to implement measures on. And finally, the last big topic for discussion is how can structures and international collaboration like Europlanet can do to help these transitions. For example, in the case of EPSC, when it was fully virtual during COVID, EPSC aimed to get this carbon neutral model of conferences. So there is already some stuff done, but what can structures like Europlanet do? So I let you spread to the different boards and discuss these topics. One of the things which is also important is I mentioned there are lots of local actions, but usually they stay local and we are not aware of them. Like the thing at the Observatory of Geneva, they don't have a website, they don't advertise it internationally. So I'm also interested to know what is happening in your institutes and locally, so we get those information back. Okay. I will go on Wova to put the link to the mural, which has the same thing right now. And you also have breakouts online, so you can discuss together by microphone and so on. See you in 15 minutes. Yes? Okay. Can you hear me? Yes. Okay, so thank you for the discussion. I think we should try to wrap up because we only have a few minutes left. And just to make an overview of what was discussed, there haven't been many things filled up in the mural, but I heard you discuss a lot online. So I hope you will fill the mural afterwards. But one of the points was actually to be able to go by train or even by sailboats to conferences. And so here in the room, we had the different boards, and it's quite interesting. I try to go from one to the other. It's quite interesting that on the different boards, we find some topics coming back, like travels. So in the board about who should act on what, we have like something about travel policies, and also to get grants to incentivize more like eco-friendly traveling, because in some institute you cannot travel to a conference with less polluting, like train compared to plane, if it's more expensive than the plane. So maybe there could be grants that help to fund the difference so people can still go. And it's something that I've seen, like travel was also, I think, mainly in the conference and meeting ones, there was like the possibility to travel at the extra cost and extra time it takes, because sometimes it's not a problem of cost, but a problem of time. That I don't remember who was telling me the story, that some of the supervisors, they say, no, you cannot go by train because it takes you 10 more hours. So it's like 10 hours you should work. So it's this is part of the community, I would say, stuff that need to change, like educate the community, like senior people maybe also, and also so that junior, when they become seniors, they don't do the same mistakes. And yeah, someone here wrote that especially for the junior members, they should not have to fight for those things, and it should be easier for them to do these kind of things. Oh, I bring back Zeppelins, and someone even put a heart to this, like added, like blimps to travel. That would be nice. That's more ecological than plane. And then we have also like a problem of having too many meetings, like in some. So one of the person I had invited for today and who couldn't present, actually, they couldn't present because the data were using science team data for some evaluation for a specific space mission, and so it needed to be approved by the science team of the mission. So they couldn't present today. But it was actually quite interesting because the result of the evaluation of this specific carbon footprint of one mission was that actually the launch of the mission is very negligible cost in terms of carbon footprint compared to the meetings. Because it's like, for them, especially before the launch, it was like 3 to 4 science meeting every year with 100 scientists going by plane. And when you multiply that, it's actually way more than the carbon footprint of a launch. Fortunately, that's why I don't give the name of the mission, but they couldn't present because it was science team data, so like private data. And so maybe one of the things that institution could do, and that's one of the issues faced by Luigi and his team, is to force people to make the data public, to have like evaluation of the footprint. So that's something also that whenever it's institutions, as individuals, there was discussion here that stuff should be like two way around, that individuals can push their institute to force to can advocate to get this kind of policies put in place. What else do we have in conference and meeting? Yes, so just little things is, for example, to use place with water fountains, so we don't have to use plastic bottles and so on, which is a fair point. I know that some, at least in where I am, we have people also advocating for this kind of small measures in meetings to really reduce the carbon footprint of each meeting. For the international collaborations, particularly Europlanet, I guess, there was like just one thing, which was to enable remote access to transnational access facilities, which we go back to trouble and reducing them. And are there any points? Yeah, there are lots of other points like regulating heating during weekends or adding vegan options. I think one thing that was very interesting for me to discover in the discussions here are the diversity in the landscape of policies from institutes. For example, teleworking. Anne-Karin was saying that when they are teleworking in Belgium, they have a bonus on, is it on the salary? Okay, so they have a bonus in the salary for teleworking, and which is lower impact. On the other end, in Italy, if they are teleworking, they have their hours counted less than if they were working in presence. So it's like the contrary of an incentive. And I was very surprised to discover this very opposite policies. So that's very interesting to know. Public transport again, like water again. So some people must have been also going from board to board, not only me. And yes, one of the big things for community and institution to work on here is to better use what is already available and maintain existing resources rather than build new stuff. So it goes into reducing the pace of new stuff. Also, some people wrote go vegans on different ones, or there are people advocating for vegans because it has a lower impact. So in the everyday policy. And share resources, so it goes with also better management of resources, which is seen to be quite bad. So yes. Okay, so I thank you all for the discussion. Is anyone wanting to have a concluding discussion? Questions? Yes? Does someone online want to summarize what you have discussed in those 15 minutes? Maybe Ulysse, I can throw you under the bus to do it.
Hi everyone. What did we talk about? So we did not have a really structured conversation. It was Luigi, Mercedes, and me. And we talked mostly about individual responsibility compared to the institutional level, and trying to understand what one can do when there is so much to do at the institutional level. And so we discussed about continuity between those actions, and we also discussed about conferences, as you talked about, the fact that there were probably too many in some of the fields and how to decide what to do. So yeah, not super structured. I also asked out of curiosity questions to Luigi, asking how his work was received by colleagues and people from the department or other people in France where he was presenting the data. So it's also interesting to see that we need to change the values of the community in some ways and make sure that everyone is on the same page, that we must act. And so, yeah, that's probably what I can remember. if Mercedes or Luigi, you want to add something, feel free to do so.
Well, if not, I thank you everyone for participating. I also want to thank again Luigi for presenting the data to us, and also I would say we should thank IRAP to let you present this kind of data, which can be seen as a bad thing sometimes. I mean, we see the problem with so many missions hiding this kind of data. So thank you very much for this presentation. Thank you everyone. I will create a topic on WOVA to keep discussing, to put back the link on the mural. I will put all those points on the mural also later in the afternoon. And I would also encourage you to post links to studies, to share information, because I think sharing information is an important point when you want to try to convince people. You need information, you need to be able to get example of what is done elsewhere to maybe convince that policies need to change and that it works elsewhere to do it otherwise. So thank you everyone, and enjoy the lunch, and see you for the next session in the afternoon. And thank you, Luigi.
Thank you for having me. Bye-bye.
Bye.